Okay, chapter 11. So here's the problem we're going to tackle, this number 2. So if you guys have it in front of you, what I'd recommend you do is either with a pencil and paper, you can take some notes on working through the problem. And if you want to use a screen, I'm going to work the problem with you, or attempt to, using some of the technology. So we'll kind of work on it together a bit. So, so you can keep this screenshot here. Let's see if I can do this with, oh yeah, that's right. I think I should be able to switch back and forth maybe. Let's start. Each firm in an office building occupies one floor of space, earns revenue of 380, and incurs a labor cost L of 300. Define H as the height or floor level of this building. The intra-building travel cost is C with the stairs of 10 times H. So it kind of ran off there. So it's using the stairs, the cost is 10 times H per floor for travel by stairs, compared to an elevator, CE, of 27 plus H for travel by the elevator. So part A is to illustrate the willingness to pay for office space for the two travel modes. And you can think about a height of a building of 1 and a height at 53. So what sort of firms use the stairs? So let's just start with the H equal 1 to H equal 53. So start thinking about how you'd start to lay that out. And I'm going to kind of work this one with you, trying to use a different function, and we'll see how it goes. Does anybody have any questions about the problem so far? Let's see. So new share. Whiteboard. You're going to have to bear with me. We'll see how this works. Okay. I'm going to try to gently flip my screen around. I experimented a little bit.
I exited the meeting. My Wi-Fi
So it's problem number 2 in your book. I don't know where you cut out at, if you saw that or not, but so we've got revenues of 380 and cost of 300. So we can just write that down. So this is problem number 2 of chapter, what are we in, 11, right? Yeah. Chapter 11, 2. I'm writing with a stylus. So is that, somebody unmute, and are you seeing the 11-2 okay?
Yeah, we are.
Okay. All right, so we've got revenues. They use just R equals 380. And we had cost of labor of 300. All right, so how are we going to figure out the willingness to pay? So what is the willingness to pay function dependent upon? What principle do we use? And it looks like Nate's up here on my little screen. Nate, what principle do we use for figuring out the willingness to pay on a problem like this? It begins with an L.
The leftover principle. Right.
Yes, but I don't think that was Nate, because Nate's muted. And I was going for Nate Johnson, I guess. I should have said that. So Nate Johnson, unmute.
Yeah, the leftover principal.
You got it. All right. So how do we set that up now that you're unmuted? Why don't you talk us through here? I'll kind of write and we'll do it together. So the willingness to pay using the leftover principle would be doing what with this? We got revenues of 380, labor costs of 300, and then we've got this height function.
Is it in chapter 11?
Yes, chapter 11. So leftover principle, well, the leftover principle is from previous chapter.
Yeah.
So what's the leftover principle in general?
Let me look at my notes.
So this is one you kind of want to keep off the top of your head. Somebody else want to check while Nate's looking?
Revenue plus.
Total revenue.
Yeah, total revenue minus total cost. So we're just looking at whatever's, we're kind of leaving out something with the leftover principle. And so we were doing land earlier with manufacturing land. And so Liz, you're right. We're going to do a profit function essentially. So what is the profit function here using these numbers? We've got, and Nate, why don't you unmute again? We'll go back to you now that we got that narrowed down. Nate Johnson.
Yeah.
So what's our total revenue? What's the profit function in general, just from micro class?
Total revenue equals, oh, shush.
And I know I'm putting you guys on the spot. It's okay to fumble. That's fine. Total revenue, that I like that part. Profits equal total revenue. And then what do we?
Total cost.
Total cost, yeah. So total revenue minus total cost. So back to that kind of basics. So now with this particular set of numbers here, what's our total revenue?
380.
380. So we got 380. And then our cost is labor cost of 300. And for the first part of the problem, we're looking at the two travel modes. So let's just take the stairs. So if we're using the stairs, the stair function was what? What was the cost for the stairs? I don't know if you guys kept that in front of you. In fact, let me just put that, I'll write this up here. So the cost with the stairs was equal to 10 times H. So 10H. And then I'll go ahead and put the cost with the elevator was equal to, this is just going from the problem, 27 plus H. Okay. So if we're trying to find the willingness to pay, first of all, for the stair people, let's put a little subscript S, the willingness to pay for the stairs, 380 minus 300, and then we're going to subtract off the stair cost, which for the stair people is 10H. So minus 10H. So that sets up our willingness to pay function, which can be simplified now since we have two numbers that stay constant. We can add those together or put them together. So we really get 80 minus 10H. For the elevator people, the willingness to pay function is different. We're still going to have the 300 and the 380 and the 80. So I'm going to do a little shortcut and just put 80 because that remains the same for both. But now we've got minus, instead of 10H, it's 27 plus H. Now I use the brackets there so that we can break that down. So 80 minus 27 is 53. If you got a calculator handy, that there's a few things that we might punch into a calculator. So if you got a standalone one or have an app ready on your laptop or whatever. And of course, minus 27, the 80 minus 27 is 53, and then we've got minus h. Okay, questions on that so far? So now the question says, illustrate the willingness to pay for the two travel modes for h equals 1 and h equals 53. So we could have done kind of a plug and chug on this if we wanted, but we could also just now look at each one of those levels. So at h equals 1, the willingness to pay for the stairs equals, we just plug it back into our function, 80 minus 10 is 70. Because we got 10 times h, 10 times 1 is 10, 80 minus 10 equals 70. And the willingness to pay for the elevator is 53 minus h. So 53 minus 1
52.
equals 52. Okay. Now I think we could do a little graphing here. You know, as you know, we usually have to do a little bit of graphing with these. So I'm going to try to shrink that little guy. I don't know, that might not even show up. But I'm going to try to squeeze it in here and see if that works. So if we're graphing willingness to pay, basically dollars on the vertical axis, and with these types of functions, remember, we're not measuring quantity of the product that we're making, but rather height. So we're looking at the willingness to pay for height. So for the stair people, what does that function look like? Like, what would be the vertical intercept? Let's see, who's on my list here? Let me call on somebody. Liz, looks like you're next on the hit list here, although we just heard from you. Let's go down to Daniel. What do you think, Daniel? Unmute your microphone.
His mic isn't working.
Oh, mic isn't working. Okay. Well, let's see. You got your chat box. You got the vertical intercept. You can type it in. What is the vertical intercept for the willingness to pay, or the stair people? Would it be equal to the labor cost? No. I'm looking for an actual number. So what would be in my graph here with, I'm trying to graph the willingness to pay. We're measuring dollars on the vertical axis and height here. So I'm wondering what we can do. So what would be, I'm going to try another little tool here.
Would it be 80?
80, good. So our vertical intercept is going to be 80. How did you know that?
Because the willingness to pay formula for stairs, the intercept is 80.
Yeah. So we've got 80. So this is slope intercept form of a line. So if h equals 0, so on our graph, if the origin down here is 0, if h equals 0, then our intercept, 10 times h is 0. So 10 times 0 is 0, 80. So the intercept is 80. So we can go on to little 80. I guess I could draw a little. This is where it might get a little tight because I've got a small graph. And then where does the graph for this one cross the height axis? So where does, think about this height axis here. Where does this thing cross? Is it here? Is it here? Are you guys seeing me track that with the little spotlight deal?
Kind of. It's a little laggy for me.
It's a little laggy, okay. So I'm looking for where does it cross the horizontal axis? Is it, I've got the little red dot on there now. Is it there? Is it there?
Would it be 8?
At 8, how'd you get that?
Basically figuring out where willingness to pay would be 0. So it'd
Yeah.
be 8.
Yep, so we're gonna take this equation, 80 minus 10h, set it equal to 0 because that's where our willingness to pay would be equal to 0. So if you do that, we've got 80 minus 10h equals 0, and 10h equals 80, and we get the rest of it. I don't know if I can go back and forth. I'd like to, I know I can save this sheet, but I don't think I can quickly bring it back up. And that might be part of this I'm gonna have to figure out. I don't know what I can do. I wanna show some of that work, but I hate to lose it all at this point. Well, I won't lose it. I know how to save it, but I don't know if I can bring it back up. Let me just try. I think you guys should be keeping track of where we're at this point. So I'm gonna go ahead and try to do this. Again, this is a learning process. Okay, so that one's saved. And then this is a little scary. Boom, got it. And now, let me come back and do that. So we had the willingness to pay with the stairs equal to 80 minus 10h. So if we set this equation equal to 0, all we're doing is finding that intercept. So 10h equals 80, h equals 8. Now you guys do the same thing with the other graph. I'm going to go ahead and draw another line here. So we got something like 8 and 80, and that's our willingness to pay function. And what's the vertical intercept for the stairs then, or for the elevator rather?
52.
53.
3.
Yeah, so it was
That's what I meant, sorry.
to pay, that's what you meant, that's okay. So 53 minus h, so again, this is just slope intercept form. The slope is 1, -1, and the intercept's 53. So now you're gonna have something over here, I'm just kind of eyeballing, but 53. And then where does this one equal 0? Or when does the, if we do the same exercise, where does it hit the horizontal axis? So if we set that equal to 0, it's going to be at 53. Okay, there I just pulled up the chat box again. I didn't see, so now I see you guys here. And that's good. Yeah, we can use the chat box. Good idea, JC. No, this time it's not a extra credit point. Okay, why would it not be 52 on the horizontal axis? 52 is at a height of 1. So if I go 1, Daniel, right here, I go up to this function and hang a left. That's 52 at a height of 1. What I was looking for 53 is when we were at the vertical axis. So in slope intercept form, 53, let me get my little spotlight thing here again. 53, oops, we go. 53 minus h. 53, when h equals 0, the vertical intercept is 53. So that's the slope-intercept form. 53 is the intercept, and the slope is -1. Okay. So, looks like we got some interesting stuff here. So what sort of firm uses the stairs? Where are the two indifferent in terms of whether you have your willingness to pay? What floor would you use either one? Go ahead and use the chat box if you, maybe some of you have already calculated it. Let's see, I'm going to try to keep my graph. Let's see if I can do this without screwing up here. Okay, that's the eraser. I think I can clear. There we go. Let's see. Erase. Oh, it didn't work. Okay. I can do this. That's kind of fun. Oh, geez, it really works like an eraser. You guys are probably all laughing hilariously if you weren't. I'm literally just erasing like my whiteboard. Oh my gosh, this is so much fun. Okay. There we go. All cleaned up. All right. So, anybody get it yet? I don't see anything on the chat box. Where would they be indifferent between stairs or?
At a height of 3 floors.
3 floors, good. How'd you get it?
I set the two functions equal to each other.
Yeah, just set the two equal to each other. So we got the 80 minus 10h. 80 minus 10h equals, what was that other one? 20, 53, 53 minus h. So again, this is the willingness to pay for the stairs. This is the willingness to pay for the elevator. And then solve this equation. So we get, if we throw the h over to this side, we get 9h. I'm kind of skipping a little bit of steps here, but the 10h goes to the other side. 10h minus h equals 9h. And 80 minus 53 is 27. 9 divided by, or 27 divided by 9 is 3. So that's just where these two lines cross. So that would be at 3. Yes, we do have to calculate JC at 53, which we hadn't done yet, had we? So let's calculate the H at the willingness to pay at 53. And JC got a -450, which sounds about right. So at 53, you're just going to plug it in. I'm going to erase this now again. On the recording, this will all should be there for you guys to track through again where I've erased, and you can go back and review if you want to. All right.
The answers that JC got are the ones that I got.
Yeah. Okay, good. So at 53, you're just plugging and chugging now. So plug in 53. So the willingness to pay for the stairs is equal to 80 minus 530. So 10H, with H being 53. So hopefully this will be a little exercise on how you guys can be showing your work. I know we were working on that through the semester, but see how I've kind of taken note at how I'm laying out these functions. And then this is 80 minus 530 gives us the answer JC got, and Eddie minus 450. In other words, if you're a stair person, you'd have to be paid to use the stairs, which makes sense, right? I mean, I might take the stairs too, but you'd have to pay me if I'm going to be working on the 53rd floor. You're going to have to pay me $450 maybe to be going up there all the time. So in other words, you're not going to be up there. And for the elevator, we've got the 80 minus 20, well, it was, I'm sorry, 53. Let me just X that out. 53 minus H. 53 minus 53. So that since H equals 53, it equals 0.
I thought it was 53 plus H.
Say that again, Aaron.
I thought it was 53 plus H.
No.
The H becomes negative when you're in that little bracket, 80 minus 27 plus H.
Yeah.
You go to both, so it become negative.
So on that first, the first profit equation, which it's on my previous screen, so I can't pull it up real quick, but it'd be 80. I can actually redraw it here pretty quick. 80 minus, and this is 27, because this is an important point, Aaron, that you have to have. It's 27 plus H is exactly what you were thinking. But the minus sign, it's minus 27 minus H. Remember the transfer through the negative sign.
Yeah, you just distribute it. Basically.
You just broke up a little bit, Aaron. Say that again.
You distribute it in the parentheses.
Yes. Yep. You always have to distribute. So then it's 80 minus 27 is the 53, which we've been working with. And then it's minus H.
That makes more sense.
Okay. Yeah, if you don't have those parts right, then you can get into some trouble. All right, so what about the last part here? So that wraps up, I think we addressed all the problems for that part at 53, and then graphically we basically did it by the way we did this drawing. Oops, I had to erase wrong. Undo. Okay, there we go. All right, so suppose that H increases beyond the 3rd floor. So this is on part B now. So as H increases beyond the 3rd floor, the view improves and workers are willing to accept lower wages. The saving in labor cost is $3 per floor. So companies that locate on higher floors don't have to pay their people as much, is what they're trying to say. So how would this work into it? So the question basically tells us to think about the elevator, right? So the last sentence, if you kind of got to read these closely, draw the willingness to pay curve for the building with elevators, including a value for H equals 53. So with our elevator now, the willingness to pay, I think I could actually go up a little higher. Let me try that. I'm thinking about it. So the willingness to pay for the elevator, if we start with that function, was our 53 minus H. So now what are we going to do to modify that to take into account people wanting to look out high floors and we don't have to pay them as much? So we got a non-monetary benefit.
Would the labor costs go down?
Labor costs are going to go down. So how would we reflect this in the willingness to pay function?
I made the 53 into 56.
53 to 56.
And would that make the overall willingness to pay go up.
Okay, but it's for every floor. So you just did kind of 53 plus 3 is 56, and then
I just said, yeah, pretty much 380 minus 97, and that gets
so I'm just going to highlight what you did. So you did plus 3.
yeah.
So that then you got 56 minus h.
Yes.
Okay. Anybody else confirm or deny?
Where did the 3 even come from?
The 3, so in the question, they say that the saving in labor cost is $3 per floor.
Gotcha. I didn't have my book next to me, so I was just wondering.
So $3 per floor. Yeah, I'm not sure I can toggle back and forth between my other thing. I'm a little scared to because I don't want to leave. I'll try that. Somebody remind me when we're done with this problem. I'll try to see if it like saves it if I come back to it. I'm not sure if it does that. So 56 minus h. So Luke, if we had the difference between being on the 53rd floor versus the 4th floor, is that capturing the benefit the same way you've got it done here?
I don't understand your question.
So you put it in as a lump sum by adding this 3.
Yeah.
And so is it better to be on the 50th floor or the 10th floor?
Technically, by the function I made, it would be better to be on the 10th because, well, I don't know. Your willingness to pay would be higher if you're on the 10th floor. And if you're on the,
I guess the different way of asking it would be, would the company benefit more from being on the 50th floor or the 10th floor? So the savings in labor cost is $3 per floor. I don't think your function's picking that up. Because the 50th floor would be more desirable than the 10th floor. And the company would actually save more money. They'd pay their laborers less if they were on the 50th floor compared to the 10th floor.
Be 3 times h.
Yeah,
Can you hear
3
me?
times h.
Oh, you
So
can hear
Daniel's got,
Cool.
instead of just 3, it's per floor is the benefit. So let me take this away. And if we now, it's still the same way Luke had it, that we're going to add 3 benefit to our willingness to pay, but it's 3h, which then gives us a new willingness to pay function of 53 plus 2h. Does anybody have any questions on that? Everybody tracking with that? Now this really made this thing kind of funky now. If you don't see it already, you'll see it as we start to maybe graph it. So it says draw the willingness to pay curve for the building with elevators, including a value of h equal 53. So let's just go ahead and put in 53. So at h equals 53, the willingness to pay equals 53 plus 2 times 53.
159.
159. So now on my graph over here, if at 53, if I start with, let me try this little arrow thing, see how this thing works. At 53, you guys see this little guy bouncing around here? You might be laggy, I guess, for you, but so at 53, we're going to go up to way up to 159, which is almost off the charts here. So let me get rid of the chat box or throw it over here. So we're like way up here. 159. So at 53, we're right up here. Oops. Now I see why I went too high. That's a point on it, way up here. Let me put my little, instead of that arrow, let's put this little guy there, my little star. At 53, this is maybe how I should have done it. We're gonna go up to here and hang a left. That's where 159 is. So that would be 1 point on the willingness to pay function. Now, what is it at different levels? So where would we graph maybe another point? What was it at 3 floors? We were indifferent before. So if we look at our willingness to pay function at 53 plus 2h, what is the vertical intercept? It's not 59, Daniel, if you just posted that, unless that was your answer to something else. JC, you now see where 159 came from? I just saw your chat. That's this equation here. At 53 floors, we substituted this new function. Okay.
So would the vertical, the pass would still be at 53, wouldn't it?
Yeah, still at 53. So back to function up here. The willingness to pay function is this 53 plus 2h. So we have a positive slope, but the intercept graphically is still 53. And so if we were to graph this thing now, in fact, I'll just take a straight line for fun, see if this works. I'll try to bring it all the way up to the, there we go. So that is your willingness to pay function. I should have done it in a different color. That would have been kind of fun. Let me try that. Undo. Okay. This is getting really beyond my pay grade. So that, I thought I could change the colors. What is that? Format? Format. Let's try red, I guess. And now line draw. There we go. All the way up to the 159 level. So the slope of that, so that red line would be your new willingness to pay function. So it is upward sloping, as you saw in the book, with elevators and other amenities. If we have an amenity like the elevator or some other feature of a building or a feature of the business, adding benefit with height, then the willingness to pay function could be upward sloping, and that's what we're seeing here. At 3 floors, why isn't it at 59? So at 3 floors, 2 times 3 is 6. It is 59. So if at 3 floors, we'd go up to my new red function, and maybe your question was after I got this drawn, but we go up to the thing. My thing's not drawn to scale. Hang a left, and it would be at 59. But the way I've got mine drawn, it looks like it's at something above 80. So remember, I'm not drawn to scale at all. That maybe was part of your question. Okay, gotcha, Daniel. Okay, so let's see. I think that takes care of that problem. Any final questions with that one?
So would a smaller firm want to have the stairs? Is that for part A?
Oh yeah, good. I'm glad you brought that up, Luke. Yeah, so what sort of firms use the stairs? So if we look at this, remember a second floor person, a 2-floor person, it would be less costly to, their willingness to pay is higher for the stair function. So yeah, let's kind of open for discussion. What was your suggestion, Luke?
That the firm that uses stairs is going to be smaller.
I don't think the size of the firm, just from the assumption of the problem, it says each firm in an office building occupies 1 floor of space, earns total revenue, blah, blah, blah. So I think we could kind of assume that it would be the same number of people, but that's a possibility. If you had more people, then that would, change part of your willingness to pay. What about other sorts of businesses? Like, where do we find retail versus, do we find Kohl's department store up on the 53rd floor of a building in downtown Chicago? Not so much.
So it'd be like buildings that don't have customers coming in and out and stuff like that. It'd be more for like offices and stuff.
Right, exactly. So where the number of trips, it would also maybe be relevant, like the number of trips that you have to take back and forth to your car, or if you have salespeople coming and going all the time in and out, and then of course customers, if you have a customer type business. So I think that would kind of fall into that category. All right, so any other last questions there? So the next one, I think I'll just kind of prime you since we have about 5 minutes left. Let me see if I can actually go to another screen without losing where we're at. I don't know if I can. Let's see, new share. And what am I trying to do? I think I'm trying to go back to this, maybe, share screen. Yes. The question was whether it goes back. So number 4 is this one. So space, price, willingness to pay for office land. The marginal benefit function of building height is 2P plus H, where P is the price of office space. Marginal cost is 4H based on the height. Illustrate the effects of an increase in the price of office space on the profit maximizing building height. Specifically show the effect from price equal 30 to price equals 60. So now we'll see if this worked or not. Back to the share, share, new share. Back to the whiteboard, share screen. Hey, I came back, cool. All right, so at least we know that. So I'm going to clear all this out. There she goes. And so we've got marginal benefit. This is just from the problem. Marginal benefit, I guess we'll go in red this time, equals 2P plus H. Marginal cost equals 4H. So to figure out where they will maximize building height, what do we want to do with marginal benefit and marginal cost? You can
put them equal together.
Let them equal together. Good. Okay, so hopefully I want everybody to graduate with any sort of econ accreditation, whether you're concentration or whatever, that we know to put those two suckers together. So then we've got 2P equals, well, I could do that. Let me just, let's see, undo the equal sign. 2P plus H equals 4H. Looks like 3H equals 2P. Again, I'm skipping some steps here. And then H equals 2/3 P. So that would be the optimal building height. It should be 2/3 of the price. And then our question says, what if our price is 30? So at 30, let me change colors here. At 30, at price equals 30, we've got height equal to 2/3 of 30 gives me 20. And at price equals 60, we've got an optimal height of 2/3 of 60. Drag that little guy over there, and that equals 40. Okay, so if the price goes up, then our height goes up. All right. Well, that looks like a good place to wrap for today.